In this video, we're going to continue with the lesson on stoichiometry using the ideal gas law, but this time we're going to do an example where you go from mass to volume rather than volume to volume. So this is example 2 in your handout. Calculate the volume of CO2 that will be produced from 75.3 grams of O2 during the combustion of CH3OH liquid at 30 degrees Celsius and 98.39 kPa for the pressure. And so you'll notice it's basically the same equation as in the previous example. So we'll just copy that out right away. So we have 2, 2, 3, 2, 4. Okay, so 2 of the methanol plus 3 of the O2, which is gas, produces 2 CO2, gas, plus 4 H2O. So your first step is writing out your balanced equation. And your next step is writing all the information out about what you have. So we have a mass of oxygen, and that's 75.3 grams over here. And we want to find the volume of CO2, which is a gas. So we know we need to do a mole-to-mole ratio to find CO2 from O2. And then once we have our number of moles of CO2, we can do PV is equal to nRT. And we can find the volume by manipulating the equation and getting that V is equal to nRT over P. And we have a lot of information here. So, for example, we have our pressure given to us. It's not at STP this time. This time it's at 98.39 kPa. We have our temperature given to us. We need to make sure we write it in Kelvin. So that's 273.15 plus 30. That's 15 plus 30 gives you 303.15 Kelvin. We have our R constant as well, so that's the 8.314, our gas law constant there. And really all we're looking for is the number of moles to be able to use this equation. And like I said, we can find that using the mole ratio for oxygen to carbon dioxide. Now, in the previous question, we were given oxygen as a volume, liters, and so we had to use our PV is equal to nRT to find the number of moles. But here we're given the oxygen as a mass. And so, as a reminder, your mass is equal to moles times molar mass. So you could find your number of moles by doing the mass over the molar mass. So that's what we'll do next. We'll find our moles of O2. So moles of O2 is equal to the mass of oxygen provided in the question, grams, over the molar mass of O2. Remember, the molar mass of O2 is 32.00 grams per mole because there's 2 oxygen atoms there, so 16 plus 16 from your periodic table. So 32.00 grams per mole. Cross grams out, and we're left with moles, and we get, so 75.3 divided by 32. We get approximately 2.353125 moles of O2. And so now we can use our mole ratio to find the moles of CO2. So we know that there's 3 O2s for every 2 CO2s. Let's make sure that's correct, right? Yes, that's right. Good. And so let's go ahead and use our conversion factor to figure that out. So we'll get the moles of CO2 is equal to the moles of oxygen, so 2.35. I'm not going to write it all in there, but I have it all in my calculator still, so 2.353125 moles of O2 multiplied by your 2 CO2s over your 3 O2s. O2s cancel out, and you're left with CO2. So times 2 divided by 3, and we get 1.5875 moles of CO2. And so now we can go ahead and plug all this information in because we have the 1.56875 moles. Plug all that information into our little equation made over here to get the volume. So volume is equal to 1.56875 moles times R, which is 8.314 kPa liters over mole Kelvin, times our temperature, which is 303.15 Kelvin, divided by the pressure, which was 98.39 kilopascals. You can cross out kilopascals, you can cross out moles, you can cross out Kelvin, and you're left with liters in the end there. So times 8.314 times 303.15 divided by 98.39, and we get 40.1855924 liters. And so our therefore statement is that therefore the volume is approximately equal to, it looks like we need to have 1 sig fig. And let me just make sure I did that properly in the previous question. Yeah, I did. Okay. So 1 sig fig provided in the question there. And so since it's 1 sig fig, we can say the volume is approximately 40 liters of CO2. So it was very similar to the example 1, except the oxygen, we couldn't use a PV is equal to nRT because we were given mass instead. So we use that equation first. And as you can see from our flow chart here, in the previous example, we were given a volume, and so we used this to go to moles. But in example 2 that we just did, we were given a mass, and so we used this equation to go from mass to moles. And then we could use our mole ratio to go to the required CO2 moles, and then to find the volume, I was able to use this one here. I didn't use this one over here because I didn't have a concentration, and it was for gases specifically. So there was no concentration given to me. I really just had pressure and temperature given to me. So if you see pressure, temperature, and moles of some sort that you can figure out, then you know you're using the PV is equal to nRT. In the next video, we're going to do example 3 with a limiting reagent.